dot again. So now we have the table we have it in now in our database. This is not minus go. There it is. So let's actually start to insert some stuff into these tables. So we can do that here, so we can actually see something. HYF3. Okay, so we know the tables we have. So start to insert some stuff and have them link to each other. We can actually take the stuff from the JSON file. Let's insert this article. So what do we need to insert first to get this article into the database? We have 2 authors and we have 2 tags. So what do we need to insert into where?
The article table.
Yeah. So if I wanted to insert something into the article table, title and content, right? There we go. Content is blah 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 blah. I'll just do a little bit of it. There's no. Just to put it all in. So now we have an article. So now we need to attach 2 authors. So what's the next step I would do?
You have to put into the author.
Yeah. Let's go back here. We have just an your name. So now I want to link these 2 authors to this article. So what would I need to do to I want to assign these 2 authors to this article. What do you name the table that has the relationship between author and posts or articles?
It was article ID. It was article.
Yeah. What columns does it have?
It has article ID.
So, what should we put into this?
IDs?
Yeah. What? Let's try it. What did I call it? So there's 3 columns, right? So what should we insert? The author ID, what should that be? Yeah. And then what should the article ID be? In this case, we only have 1 article. So, 1 as well. Now, let's run that. So now we have we have one author connected to this article, and then we need the next one. That would be 2. Cool. Now we have 2 articles, 2 authors on the article, and then we need the tags. Any, what table should I do?
Tag.
What? Sorry?
It's the tag.
Yeah.
Inside.
Let's just do it here. Oh, that was the wrong button. Values, and then what do we call it? Science. I think maybe I can do this. Let's try it. Yeah. Now we should connect the now we need to connect article and tag. So what table do I need to insert into? Which one of these? Yeah. Okay, let's insert into article tag values. Article 1, tag ID 1 is pretty easy. And then let's do it here as well. Article 1, tag ID 2, I'm guessing. Perfect. So now we have everything we need for Article 1. So now we can actually do some queries on it. Let's do one where we join the article table with the authors. So what I need to do here?
Text data.
Yeah, let's do it in here. So we need to select article dot. Let's find the article title and the author name.
Yeah, article title. Then we use article title and author name.
Yeah.
And
from what?
From article and we should use inlet line. On let's say post. I have a different table name.
Yeah, we have the show table, so we call them this. So we should join on this one, right?
Yeah.
What was it called?
Author ID and article ID. Article ID.
What am I? Sorry. Author ID equals.
Article ID.
No, it's the same.
So like this.
Save that.
It will be author ID equals to author ID.
So the thing is, right now we only have the article table and the author article table, right? Right now. So if you do describe article, and describe author article. So these are the only 2 tables we have.
Yeah. Then we author ID.
So we need to join the article table with this table. So what columns do they have in common?
Yeah, author ID and author ID.
Author ID is only in this table.
Yes, in the
ID equals the article ID.
Exactly. So it should be article.id equals article ID. So let's see what we get here. If I see what we get when we run this. Oh yeah, we can't do that yet. So let's just temporarily remove that. Let's say author ID have a result here. We have the title of the article, and we have the author IDs. But we actually want the author names, right? Because we can't really use author IDs very much. So let's say we actually want the author name. So what do we need to do now?
One more join, the inner join on author, and the common thing is author ID and equal to
Exactly. See what it blows up. Perfect. So now we joined across the two tables. We have from article all the way to author. And yeah, we could do that. We could also do join from article to tags if we wanted the same principle. So yeah, you can. Any questions?
Is that author ID? You didn't use the ID from the JSON file.
No, I could have. It's just this one automatically generates my IDs.
Okay.
So we could have said, hard coded into 42 and 12 and all that stuff. We just didn't do that. Yeah, maybe we should change this to 1 and 2 and so forth. But let's say we have 50 authors in the table, then it would be the case. In this case, we also generate the IDs when we insert. This many stuff makes sense? Okay. Let's have a look at. So you just used, or some of you used this thing to create databases or to model them. So I showed you how to reverse engineer. Here, tools. Where did it go? Database. Reverse engineer. Here it is. Control R or Command R. To show this, to generate this from that. You can also go the other way, as I think I showed you, Darian. You can generate the tables in here, and then you add all the columns, you add all the indexes and the foreign keys and relationships, and then you get this stuff to write the SQL for you. And it just, so this, if I wanted to, I could probably, don't know where it is actually. I think I can generate a database from this.
Save model.
Yeah, so I can actually create table script. So let's say desktop. Yeah, we don't. There we go. Then we get the actual SQL code that's needed to create all these tables. So it does it for you, all the stuff you need. It's nice to know that it's there. I rarely use it for anything, except if I'm generating a new database for a new project or anything. For most projects, you have an existing database already. It can be nice to be able to show the structure of a database. Sometimes you have 50 tables in a database, and being able to show them graphically usually gives you a better overview of how the database is connected. So you can use this tool to generate databases. There's also other tools. I don't know what they're called for Node.js, but there is what's usually referred to as an ORM, Object Relational Mapper, which is a way of mapping your objects to databases without you having to do anything SQL. You don't have to do a lot of SQL at least. So let's say in Node you have a car object, and you have a client object, and you have different objects. Then you can make the ORM generate the database for you, and then the ORM writes all the SQL that you need to save and update and delete and attach them to each other with relationships and stuff like that. I don't know what they're called for Node.js because I can't remember. I guess there is.
There's probably a lot of different libraries.
Node.js. Let's try that. Yeah. So just the first one I can think of here is there's an ORM for this. Maybe you're going to use, maybe you're not. If you're going to use them, the ORM can do, like, usually what I found is the ORM can do like 80-90% of the stuff for you, and then sometimes you have to write your own SQL anyway, because it's not fast or efficient to do it directly in the ORM. And even if you get the ORM to do it for you, it's still nice to know how it works, because as soon as you have relatively complex databases and complex tools, then you will need to know the raw SQL anyway when you're doing queries for it. Just cover this. So we covered also, so maybe in the beginning we talked about MongoDB. I think we mentioned that. We just had a lot of stuff about MySQL, which is a relational database where stuff has relations to each other. But you can also have other database systems where you don't necessarily have relations to other data. You can have usually what's referred to as NoSQL databases, like MongoDB or what's it called?
CouchDB or
yeah.
There's a lot of different.
Yeah. Where you can, so MongoDB is a good example where you can basically just store a JavaScript object. So you just generate your object and throw it at MongoDB, and MongoDB says thank you, and here's the ID of the object, and then you can fetch it.
So, for example, in that scenario which we build our RDB relational database, in MongoDB we need not to build the tables.
Yeah, exactly. You can insert whatever you want. So you can insert one entry with 10 columns, one entry with 50 columns, one entry with nested arrays, and all that stuff. So you can insert whatever the hell you want. It has its advantages, it's really fast. But yeah, there's also disadvantages to it. I mean, you don't necessarily know what the data is going to look like because there's no schema on top of the data. So in MySQL and the SQL databases, you always have a schema that says, well, in this case, we'll say, well, you know, an author has a name and an ID. So you could have an author collection or an author database in MongoDB as well, and you could, you know, say, well, okay, it has an ID and a name, but there's no way to. It's not usually enforced that you have to have a name or that you have to have a birth date or whatever it is. But you can store whatever you want in it. It's really fast, and it's good to store JavaScript objects if you're getting in and out, and also if you have non-relational data, that's fine. But this also comes with the shortcomings that you can break the rules if you want to.
Which one we should choose? Or we are building our shopping cart or something like that. So
Different types of databases are good at different things. So there's no like one solution catches everything choice. I say for most web apps you're going to be building, stuff like MySQL is really good. You can use MongoDB if you want. Let's say you wanted to build something like a Twitter clone or something like that. You could do that in MongoDB because it's usually faster for stuff like that. It also has some advanced features has some features that most SQL databases do not have. I'm not a big fan of MongoDB, so maybe I'm a bit biased in this regard, but because I've had some troubles with it. Among other things, I've seen stuff like, so if I'm writing stuff to an SQL database, let's say I insert a row, and I get back one row inserted,
yes.
right? I know that's been inserted, and the next time I'm going to run something, I know that row is going to be there, except if someone else deleted it, but you know it's going to be there. I've seen stuff in MongoDB where I have a piece of Python code that inserts some stuff into MongoDB, and I see the thing 5 entries inserted, and then I connect to the same MongoDB database with another client, and I try to find those entries, and they're not there. And then I wait 10 seconds, and then they're there, which is really confusing when you're trying to do something, especially if you're doing it from, you know, some sort of scheduled job or whatever it is. It might be a bug, but it's still a relatively new technology compared to many other databases that are in use. But a lot of platforms use MongoDB and other stuff as well. And I think also Postgres has added some NoSQL features.
Yeah.
So some of the other
We have
databases.
a JSON data type.
Yeah.
So it's a hybrid in a way.
Yeah. There's also this is basically there's an advanced, what do you call it, a very confusing definition of normalization of databases. The most basic, smallest example, which is a really good example, is let's say you have a table of users, and those users are customers in your store, and those users have an address. In an address is usually a zip code. So you have a table of users, which is let's just actually add an address to this author table. Author add column zip code. What is the zip code in Danish? Always 4 characters, right? Okay, so now in the author table we have I accidentally delete. Now we have 2 authors in the author table. Let's say they live in the same zip code. Let's say they both live in Frederiksberg. So now we have these 2 authors, and they have a zip code in 2000, and they live in Frederiksberg. So here we actually have duplication of data, right? Because we have Frederiksberg, the city, is dependent on the zip code. So let's say we have 2 users in Frederiksberg. That's double the amount of storage needed, right? Let's say we have, I don't know how many people live in Frederiksberg. Let's just, if you imagine we have 10 million users who live in Frederiksberg, then we would actually be storing 10 million times the amount of data that we need to say that they are living in Frederiksberg. So then what we could do is extract this column out into a separate table called city, and the zip code is the primary key and the city is the name. So then we create a new city, a new table called zip code city or whatever. And then in here, the only thing we do is actually just writing the zip code, because then we know we don't have to store Frederiksberg a billion times. We only have Frederiksberg one time, and then all the people who live there have reference to it, like a foreign key, one time per user. So that stores the minimum amount of data to what do you call it, to satisfy our needs. And you could think of that with many different properties as well on users. Or on databases in general, that you can, if you have everything in the same table, usually it's faster to select from it if you have everything at once, but you need more storage to have it there. So you could leave it in the user table, but it's usually a good idea to have it separately if there's a what do you call it, a company, what do you call that? If it's if the city is derived from the zip code, which it is in this case. There are other types of normalization. I can send this link. I'll send it on Slack. It's a bit of a long read. It seems complicated, but once you get get into it, it's not that complicated. It's basically just avoiding duplication of data and spreading stuff into dividing stuff into table so that it makes sense. So we have the same example here with authors and books, that you can save. This is the first example. A book has 2 authors. Well, then if that author wrote 500 books, then you're going to have duplication of data, so you move the author out into a separate table, and then you link a book to an author, like we did with articles before. Let's see. Okay, anything else we need? I don't think so. Yeah. So before we start, I think we can either use some examples, or we can start with defining the homework. Any questions? Yeah, we can elaborate on that. So the floating point is the different ways of representing numbers in programs. So the example we had before with so this I think actually is going to say 0.3. Yeah, so I think we can round it. Oh, maybe it actually does that.
It might default to decimal or something.
Yeah, maybe. Let's try it. Can we do this? I don't know if we can do
I
this.
think we can.
No, we can't. Okay, how's the cast to float?
Okay.
Cast?
And then the type.
Cast. Maybe this works. No, it doesn't. This is in Node.js, I think that's easier. So this is a Node.js console, right? So this should be, if you like logically, if you're doing this on a calculator, you'll say that's true, right? But it's not, because 0.1 plus 0.2 is equal to a lot of zeros and then 4 at the end. And that's because storing decimal or floating point numbers on a computer, which is a system that uses binary mathematics, or binary logic, whatever you call it, not all floating point numbers have a representation in binary. Which means that you cannot actually correctly represent this piece of math in floating point. You cannot correctly give the result because it's not always it's not always 100% accurate when it comes to doing floating point math. But it's really good at stuff like 3D graphics or whatever, because if let's say you're making a game or a chart or something, no one is going to care that a chart is 0.00000 whatever 4 pixels off, because that's never going to show anywhere and no one's ever going to care. Or if you're doing average values of something, it doesn't matter that it's 0.004 off. But if you're doing money transactions, let's say you're a bank and you're receiving 10,000 transactions per second for people who use their credit cards for something, then this adds up and it gives you, I don't know, we call it rounding errors. It means that the amount of money that's being spent is the amount of money that you, let's say, you withdraw from people's accounts and stuff like that. So you always use decimal numbers when you do that, for example, in MySQL. So MySQL has this data type called let's see, decimal. Yeah, so we can try and create a table with this. With this data type. Let's try and create a table called product. Let's do it in here so we can see something. So create table product. give it a price. Let's just say, I don't know what the biggest is, whatever, something like this. So then we create this table. Let's create this table. There we go. So now you have a product table we can insert stuff into. Bucket, whatever that is. Just say 50 krona and 19 euro. So you get the price out. So all the math that you ever do on this price field in MySQL, it can be sums, it can be plus, minus, multiply, whatever it is always going to be 100% correct. You're never going to get a remainder where like you do in floating point math. There's let's see if I can find a video. So this guy, I don't know if you know this guy, does YouTube videos, and this I won't play it, but I can link it.
People expect computers to be.
I can link it in Slack, and he explains down to the hardware level why this happens. It's not so important that you know why it happens. The important thing is you know that it happens. So you know that if you're doing anything with products or prices or calculations of taxes or whatever it is, money, something that needs to be precise, then you should use decimal data types in MySQL and to avoid having these issues. So I'll just link it in.
He also has a very great video about time zones. Actually.
Yeah, he does. Actually, let me find that one. I'll link it as well. There it is. So he mentions the stuff for Gaddafi, among other things. Let me just link this in here as well. Yeah, I don't think we miss anything other than this. So let's start. The homework is a bit open-ended this time. So the homework is think of an application that you want to do, and then design the data model for it. So design the this. You can do it in Workbench or whatever, or just do it by hand, whatever you do. So design the model behind your application, and then create the databases, the tables and the relationships and all that stuff. Write the create table tables, and then store them in an SQL file and send it in as homework. So you could, previous students have done stuff like modeling a library, or a school, or a grocery shop, or limited version of Facebook or Snapchat, or whatever you could imagine you wanted to model in the database. So there are some let's see. Yeah, it says your application must include at least one many-to-many relationship and any supporting tables that are needed. So you can't just say, well, I have a user database and it only has one table. That's a bit boring. So do something that has a couple of tables and some relationships. So it's kind of the same exercise we did with the author and the article.
Maybe include a bit of example data as well.
Yeah.
We have an example of listing.
Yeah, we draw a Facebook on there.
Put the whiteboard image up on as well.
Yeah. I'll just stop recording and then.